Yeah. So I'm Ketki Singh and I'm from the batch of Production Engineering 2023. And I, along with Varshini Priyaa, will be hosting the session today. Varshini, would you like to introduce yourself?
So hi guys, sorry for the delays. So I'm Varshini and I'm majoring in mechanical engineering and I'm a data center enthusiast. So yeah.
So I welcome all of you to the Data Science and Robotics Huddle. An honor and pleasure to have you all here. We have an amazing lineup of speakers and I would like each one of you to introduce yourselves. So let us start with Deepti ma'am. Ma'am, could you please introduce yourself?
Hey guys, this is Deepti and I'm pursuing my master's in CS at NYU Grant. And currently I'm interning at Yahoo as a research data scientist. So it's so nice to meet you all. Like it's been quite some time. I think I gave a speech last year. So it's so nice to come back for another. So thank you so much for having me here.
Thank you for being a part of this. So next, Ravitha ma'am, could you introduce yourself?
Hi guys, first and foremost, I'm mom of a 6-year-old boy. That's how I like to identify myself. And he has taught me more than anyone else in the entire world has. So on that note, I'm 2001 batch, production engineering as well. Same like Kirti.
Ketki, it's Ketki.
Ketki, yeah.
Ketki, yeah.
So yes, the same like you. I started my journey, even though I was production, I didn't enjoy what I was doing during the engineering years. I just wanted to get into RSC Trichy. That was my goal. So I just did production engineering and was placed in Wipro Technologies as a software developer. So I started my journey in software. For the first 10 years, I was doing software engineering. And then I changed field. I went into consulting, and consulting taught me quite a lot of stuff for a couple of years. I was there. And then moved into product management in the mining industry. And ever since, I think for the past 7 years, I've been looking at the autonomous solutions, and for the past 2 to 3 years into data and analytics. So all of this is in the context of mining engineering is what I will be talking about with you guys.
Thank you, ma'am. Can't hear to hear more of your experiences. So next can Akshaya ma'am can you introduce yourself, ma'am?
Hi everyone. Am I audible all right?
Yeah, you're audible.
Okay. Hi, this is Akshaya. I am currently pursuing my master's at CMU in robotics. I did my undergrad in computer science, and after that, I was pretty inclined towards robotics since undergrad, and so I participated in quite a lot of robotics-related activities on campus, including the clubs. And currently at CMU, I am looking at multi-agent systems, how to more towards the algorithm side than anything else, more how to coordinate among multiple systems, how do you do simulation testing, what are the pros and cons, different kind of applications you can have for a homogeneous or heterogeneous multiple agent systems. So that's what I've been working on. I'm really happy to be here. I hope that many of you get a little something, if not a lot, from all of us who are speaking now. And I'm glad to have some of my friends also on the call, and hoping for a good session going forward.
Thank you, ma'am. We are glad to have you as well. Vidya ma'am, could you introduce yourself?
Yeah, hey guys. So I'm Vidyaa from Instrumentation and Control Engineering batch 2020. So right from my undergraduate in NIT Trichy, I've been towards robotics and autonomous systems. And fortunately, I've been lucky to be in the same path, in the same field as that in Harman International, where I came to know that they had a ADAS team, like autonomous system platform team. in Harman, and I was fortunate to get into it, and um, I was fortunate to get to know many people who do MS and PhD in autonomous systems. So that's how I decided to pursue masters in the same field. So right now I'm an incoming grad student in Purdue University. So yeah, I would like to share whatever I know, like whatever I've been through till now in the same field, and hope you guys get something out of it. Yeah.
Thank you. Thanks a lot, ma'am. So, everyone, this will be a very interactive session where we'd want where the mentees will be able to learn a lot from the mentors. So, could you please turn on your cameras if possible? So, this is a general overview of what we are going to talk about today. We're going to talk about data science and NLP, perception and control in autonomous systems, autonomous solutions and data analytics, and research in robotics. So, to begin with, let's start off with an icebreaker session. So, Varshini will put up a link in the chat box. Are you guys able to see the link? So type in words that come to your mind when you open the link.
So guys, we'll give you like 3 minutes. Like so, quickly like add in your words, like whatever words you wanna ask them. Something related to both robotics and data science.
So should we type a word, or what should we?
So with the link, like I've sent you a link and a code. So what you do is basically enter the code in the above link, and you'll be able to like add in your words.
Okay.
Yeah. Are you guys able to view my screen?
Yeah.
Okay, so we'll quickly have this icebreaker session. So each one of you could take a word and start talking about it. So, Ravitha, ma'am, can
Okay.
you start? Yeah.
Yeah, I'll start with I entered human machine interface, so I'll start with that. Most of the automation right now that we see on a day-to-day basis has got some kind of, it's commonly called as HMI. It's a human machine interface. So it relies on, what it means is it relies on a human to input some data so it can make decision based on the input that's been provided. So that's what is human machine interface. So I'll let Deepti, Akshaya, and all the techies to take other words.
I'll go next. So I'm going to pick the word bias. So bias is like everywhere. So it's very important because it might look like not a prominent factor, but it hugely affects your analysis irrespective of the field. So you should be very, very careful, especially the most common bias is the selection bias, where, for example, just pick a small part of data and then think like, okay, I'm going to analyze this, but it might be possible that in that part of the data, you just pick, for example, males and not females, and then you concluded something, and that's not right? So that is something like a crucial factor where you might waste like a year or two in a very deep research, and then at the end conclude that oops, it's a selection bias, it's completely wrong. So it's very important to be super careful about any kind of bias in any field, especially in research, in long-term research.
Okay, so I would go next. I would take the word training. Why training? Like I would wonder what is this machine learning thing all about, and it's just a term going all around. Like anyone uses it, and anyone says that they have been learning it. So I used to wonder what's the impact of machine learning. So there comes the word training, where you can solve any puzzle. If you take, if there are the number of outcomes is fixed and finite, then there's no need of training. But when it comes to, say, autonomous systems and an outdoor environment, there are so many probabilities, and there are so many things to learn from the environment. So there comes the training, where you need a lot of practical examples to get training from it. If there's something fixed number of outcomes, then there's no need of training. So I understood. It took me a long way to understand what is the meaning of training and how it impacts the technology today.
Thank you, ma'am. Akshaya, ma'am, would you like to pick up a word and speak about it?
Yeah, sure. Actually, when I started entering the words, I was not sure that we are doing actually related words. So I entered like carrot cake because that's what I was thinking about at that moment. But if we're talking about technical things, I can pick up path planning. That's something I'm working on. And path planning is, initially, I thought it was a very simple problem. You want to go from AD to CD, and you just avoid obstacles. But path planning is a very interesting field when it comes to when you have to look at dynamics of each robot. There are some robots which can move only in compass directions. There are some robots which can move in any direction. There can be dynamic obstacles in your environment. When you have multiple agents, it's not just the obstacles in the environment. You have to avoid robot-robot collisions too. And there are so many other things that comes into play. So path planning is a problem that in itself can be very complex, but is often used as a modular part of a bigger problem. When you are, for example, when you are doing a complicated algorithm for multi-robot coordination, path planning is kind of considered trivial and it is considered a solved problem, but it in itself can be a very complex problem and a very interesting problem if anyone wants to read further about it. Yeah, that's path planning.
Actually, I was going to ask someone in here to explain what carrot and cake. I thought they were some technical words and deal and CV, but thanks for saying you just thought of carrot cake.
Yeah, when they said what are you thinking about, I'm like, okay, carrot cake is what I'm thinking about right now.
Sounds good.
Thank you all. So, can anybody pick up classification? Deepti ma'am, would you like to speak on classification?
Sure. So classification is like a very trivial problem because there are like so many things around us that we perceive, and the first thing we think about looking at an object is like, how do I classify it? What does it come under? Is it a living, non-living? Like as basic as that. So it's kind of like a trivial problem, which is going to be it itself is not like a bigger problem, but it's going to be an unavoidable part of a problem when you're solving something big. So yeah, pretty much. So it's something that you would start with in machine learning. It's like, like baby steps. So that will be your very first step in machine learning.
Yeah. Thank you, ma'am. So does anybody else want to pick up any word and speak on it?
I guess let's ask the audience which words they're more curious about, and then we can go from there. Girls,
I would like to know about image processing electron.
That's not my field, so I'll leave it to the others.
Somebody wrote in the chat box, Sophia. Sophia is in the robot, Sophia.
Yeah. It's not exactly, humanoids are not exactly my field, but I can talk about what really fascinated me about Sophia. So in most of the humanoids that we're working on, that's currently being worked on from Atlas, Sophia, and some of the new humanoids that's being worked on in UK, each of them have their own specialty, even among humanoids. Some of them are really good at reading expressions. Some of them are really good at locomotion. Like, for example, Atlas, I'm sure you would have seen it doing backflips and whatnot. And Sophia, I think, is best in terms of like interaction, human interaction. It's able to hold a conversation. It's able to smartly reply to whatever you're saying. In that sense, what really fascinated me was about how they are able to mimic human expressions on the robot, on the face. Maybe like a smile, a smirk, eye contact. And these are things which for a human is very natural, but to make a robot do that is very hard. And so that's something I find fascinating about Sophia.
Yes, and one more thing, as she said, the way it interacts with people, the reply that it gives is like amazing. Like even we wouldn't be that having that much of aptitude to reply in that manner. It seems professional as well as a fitting reply. So yeah, I would just wonder how well they have trained the robot.
Thank you. Thanks a lot, ma'am. I think we can go ahead with our speakers. So I'll present my screen, and please let me know when I need to change the slides. So Deepti ma'am, would you like to start?
Yeah. So I'm going to talk about data science and, to be honest, machine learning in general. So next slide, please. Yeah, so what is data science and machine learning? I'm sure every one of you guys would have Googled it at least once. So I'm not going to repeat the same statements, but I'm going to give you what I think they are. So I just wrote like, like a few terms that are relevant to it, but you might think I repeated a few words like statistics, but it's intentional because it's super, super important for both statistics and probability, to be honest. because if you have a good grab in both these concepts, then everything is kind of going to be a piece of cake for you with respect to understanding what's going on and why do they do it. Because right now, the one thing I see is that people are being aware of machine learning and the different models. They use the GitHub repository, which is like really cool. But then if you ask them, what do you see in that? Like, do you know why they did that? Do you know why the architecture of the model is that? They have no idea. So that's something that will make people stand out, and that's where it shows the actual passion for machine learning. So for that, statistics and probability is going to be a great help. So it's always good to brush up those concepts. It's never like you learn everything at one go, but you will keep learning as you work on different projects, and you keep going back and forth. So starting with that, and the second thing is a domain understanding, because data science and machine learning are just concepts that you will apply in different domains. So whichever domain you go to, it's very important to understand the domain so that you will know where you can apply, what you can make use of, and like how you can contribute to that domain. So that is very important. That's equally important to understanding the concepts itself, and how to work with or without data. I know data science kind of translates to like science in data, but it's not really true because you don't really have data for everything, especially if it's a research data science where, for example, you need to get some insights about the competitors. So in that case, you don't have the data about the competitors. So you need to see how to think out of the box and think from the data in the company that you're working in to see how the others are performing. So it's more about understanding the market and understanding the concepts, domain, and thinking out of the box, trial and error. Like that's how research goes. And in addition to that is intuition. So intuition works very well in data science because once you have the data, or once you collect all the necessary information, you are going to use your brain to look into it, identify patterns and everything. But in machine learning, you're trying to automate everything on a larger scale. So in that case, you hope that the black box works, but that is quite random. So in order to make it work like how you want it to, you need to make sure the architecture that you propose for the model makes sense to the problem that you're solving, which again points to statistics, right? So that's why more statistics and maybe a little more, there's always this thing that comes throughout, like you always feel like it's not enough. So that's something which is okay, but which you will keep learning it. And within machine learning, again, there are quite a lot of subfields. Like there are like people working purely in the neural network architecture, the hyperparameters, like is there a way to fine tune the hyperparameters in one go? Because right now that part is like a trial and error. Like how do you decide the number of epochs do you need? How do you decide how many layers of the neural network you need for your problem statement? That is still something unsolved. That is something that's still a trial and error. So people are working on that, and there are also people working in niche fields like NLP, computer vision, and with this with deep learning, that there are like these cool energy-based models where they integrate physics and machine learning together, which is like super cool, and it's solving so many things nowadays. And if you see, like recently in Meta, they proposed the one translator that can translate English to 200 languages. And all of those things we read about it, those are all like based on the energy-based models. So that's the prime focus, at least in Meta AI. And there's also like computational biology, where you work with genetics and, like automate so many things in the genetics field. So once you have a catch in the general concepts in the machine learning and the statistics and the math behind it, you should be very easily able to grasp all the concepts within these niche fields, and then you can pick the one that fascinates you the most. And that's how like people try to narrow down their focus in the long run. And irrespective of the field, so this is something that is like not specific to data science and machine learning, though I wrote the questions along those lines. But these are like the required questions that you need to ask when you're given a problem statement. First is question the problem statement itself. Don't accept the problem statement. Do you think it's right? Or is it like when they give you a statement, try to understand, like, is it based on all the factors, or are they being biased in just one factor? Because you can't like filter out during your process without knowing if it is for a general population or is for a specific population. So you need to question the given problem statement. That is like super important to understand. And once you have the good understanding of the problem statement, the next question is, do I have the required data? Sometimes you don't have, you might have to generate, or you might have to just collect around, scrape by yourself from the websites, etc. So it's very important to make sure you have the right data at the right time, and also ensure the quality of the data is good. And once that's done, what are the next steps? So with respect to data science, it's about like, once you have the data, how am I going to slice and dice along? Like, how am I going to filter the data? How am I going to look deep into it along different aspects? And that's all based on the problem statement again, right? So for that, it goes back to the first point. You need to know what you're solving. And with respect to machine learning, what architecture am I going to choose, and what should be the complexity of my models? It's not wise to always use a very complex model. It's going to unnecessarily complicate the results. So you should decide on the complexity and everything. So all of those things come under the procedure. And what tools do I have? Do I know the languages? Do I have all the frameworks and the necessary tools to implement all of these things, both in data science and machine learning? And once you implement that and you have the results, how do I analyze it? So I have this results from the data science. These are the results from the data. What do I get out of it? What do I understand? Is there something weird going on? Is there something weird? Do I want to go deep into it, or is it just is it going to like bring a big impact, or should I not waste my time there? Or like all of those important decisions. And with respect to machine learning, like, how good is the output? Do you think my model is performing good, or should I make more changes to the model? So those are the next level questions. And the last will be what are the insights that I finally get? Like, what do I get out of it? And did I actually automate my model? Is my model giving me right data to implement it in the real world? So that is with respect to the end result. So these are like the 5 major questions that you ask to break down a given problem statement. Otherwise, it's going to be too scary and you'll get lost in a rabbit hole, because there are too many things nowadays, at least with respect to both of these fields. So these are the things that's very important to go line by line. It's not parallel, it goes in series. And one useful trick that I recently learned is that when you're given a problem statement, try to write questions on it. Like, how would you question it? Just don't have it in your mind. Write it down in a sheet of paper or in the document. Like, start with a higher level goal. What, for example, the high level goal can be like, what is my impact in the corporate world? Like, what is my goal? Increase the revenue. And then how am I going to increase the revenue? How do I measure the revenue, and what is to be done? So it should be like a hierarchy of question. And then so it goes from higher level, and it breaks down to smaller questions, and then you try to answer from bottom up, because the lower question is kind of answering the upper one, and then you build slowly, and then you reach the first question, which is your goal. So you have your answer, that you solve the problem statement. So that makes it super easy to track, so that you don't get sidetracked from the research, because that sidetracking is quite common nowadays with respect to research, because people are not using this kind of a trick to make sure they're in the right track, right? And so that's something I found super useful, and I'm trying to implement it. So I hope it'll be useful for you guys. Next slide, please. So my journey so far has been like, I did biology in my high school, and then I didn't like it, so I wanted to switch. And then I got CS at NIT, and I just went like, yay! And then I just like came in, and then I went through so much, because like it was a huge transition, because I was like one of the smaller set where I was completely new to what C++ is, what Hello World is. I had no idea. My friends were all like too much into it already, data structures and everything. So it was super scary, but I guess somehow I got used to and learned more. And I heard about machine learning in my second year, but at that time we didn't have like women inclusivity network or like groups where you get to know mentors and stuff. So I was like kind of like left on my own. So I just like started looking into so many stuff. I kind of understood that, okay, there are like too many stuff. How do I start with? I had no idea. So what I did is that I went to a professor in the CS department and I expressed my interest and I want to start with it. Give me a simple project. Let me start there. I think that you would know, you're in the field, you would know if I'm in the right direction. And then she liked my passion. She gave me the project and it was a very simple project based on neural network, like very basic. And I have linked to a few of the projects to my GitHub or the papers that are published. And then after the neural network project, I like started working on smaller projects because I was interested in quite a few stuff. And then for third year summer, I got the international opportunity at NTU Singapore to do machine learning internship. And there I got introduced to graph data. I had never worked with that. So it was pretty cool. And one thing I made sure was that undergrad is the time to explore so much. You have, because once you're deep in the career, it's so hard to switch. So this is the point where you explore so much to understand which one you're interested in more. So I made sure that all my projects are in different fields and where I don't repeat it, so that I can like pick a field for my master's or the PhD following master's. So graph was something completely different. And then with Akshaya and my other friend, we did the final year thesis project. And that is based on that we developed a learning management system. And after so many pain, we finally published in the journal. Okay, I'm not going to that area, but yeah. And then after I graduated, COVID came, unfortunately, so I had to like defer my admit. So the 1 year I really wanted to work on a 1 year long research project, which was not that feasible during the undergrad. So I used the COVID year and I worked parallelly in 2 1 year long research projects. One is NLP investment banking under JP Morgan, and the second is the single cell sequencing, that's the computational biology. I wanted to try to use my sleeping biology knowledge and try to integrate with CS. So I thought, like, why not try to go along? And I really love both. Yeah, it kind of led to more confusion than clarity because I kind of liked everything, but sure. And at least I was happy to explore more. And then now I started my master's. I started last fall, and I take all ML focused electives, of course, and I'm getting so much exposure here. And right now, I wanted to. I worked so much in the research aspect in machine learning. I wanted to try something in the research area in data science, not a corporate data science, but more like a research. So I was fortunate enough to get an opportunity, and here I'm working on the competitor insights. I can't talk more about it, but it's something along those lines. So it's the same situation. I have no data about the competitor, but I have to give them some insights about them, how they're working. So it's super cool, super challenging. But yeah, like I'm learning so much, and ... I still have more. I'm still a student. So next slide, please. Yeah, so one thing that I wanted to share is that there are so many resources around. You guys will have no idea which one to go to. Even I have no idea in so many things. Like I hear so many courses, I'm not sure. So I think the first thing to make sure that you don't waste too much of your time is to just ask. It's so simple. Just ask around. Your friend might have done the course and be like, no, don't go there. I don't think it's useful. You can ask the mentors, like not just mentors assigned to you, but anyone or literally anyone in the field. There are so many platforms nowadays. People are so reachable, so kind. So you can just like go ahead and ask before you jump into courses. There's just too many. And I would say don't just learn the concept. So once you understand the concept from these courses, try to implement these concepts. Like you might have like when you learn the course, the human brain tries to attach the concepts to some applicative field. Try to write them down and try to implement and see like if you can, like you might do something great out of it and you can make it just a big project, who knows. But you should try to implement and see, not just learn and like put everything in the brain. And also try to appreciate the math behind it, which I don't find many people do. I know it's quite hard, but it doesn't come in one go. I'm still learning. Like I'm not an expert in any way, but I'm still learning. Experts still learn the math behind it. So, but I would say don't ignore the math completely. Just like appreciate it and try to learn, if not understand. and try to implement like small projects. Like that really helped me to grab like the initial internships, because once you have the internships in your resume, it's going to be a little easier to show your previous experience and passion. But the getting the first or the second internship is going to be very hard, because you need to make them believe that you're going to do something good for them, right? So it's always good to show passion via these small projects. This not just helps with internships, but also with your hires application, because people here see so much, appreciate so much about the passion that you show to the field. And also the same thing as before, like people just use GitHub and try to like implement the model, but you would stand out if you actually try to read the paper or the blog that they link to it. Because if you just have it in your resume that, oh, I did this project, I used this the model in GitHub, the first question they will ask is, why did you choose this model? Do you know about this model? Can you tell me what you found that is good in this model, something to improve? If you answer that, you're really going to stand out of the crowd, because not many people are doing it. So that's some advice I always give to anyone who asks me, and that's something I always do, and that helps me a lot. So, and also helps you with better understanding. So why not? And in parallel to learning all of these things, what's the point of learning when you can't like communicate it to people or try to write it down for yourself at least? So the writing or the presentation skill is super important, because that literally projects the work that you do to others. So I would say just like try to write like a short blogs or like a short notes to yourself. Like you don't have to post it out in public, but like as you learn every concept, write it down. So with writing comes the practice, right? Like it's just like you get used to it. And for the visualization, it's like a super important key, because if you say human brain, when you speak, they just grasp 50% of what you say, but when you actually put the results as visualizations on a slide, they're going to get it 100%. You don't even have to speak. They're going to be awestruck. So visualization is super important. And there's this book called Made to Stick that I've started reading now. I heard so many good things about it. I've actually linked it to the slide. So you guys should like try reading it too if you're like really interested in tuning these kind of skill. And I've also linked to another like a 25-page summary of a book where it's like how not to write presentations. I think like how not to sticks to us more than how to, right? So I found that to be like super useful. And also like in order to get to write like a research paper, if you guys are interested, try to like whenever you do a project, try to write a short paper for yourself. And then when you try to present the project in your resume, you can like link it to your short papers. You don't have to like publish it. If you publish it, great. But if you don't even if you don't publish it, like people just look at your writing and then they will go ahead. Because to be honest, my first project, the neural networks, I was able to publish because the professor really liked my writing. So she was super impressed and she wanted me to publish it. So that really helps. The writing really helps. So moving ahead to the master's application, as I said, people here value your passion a lot more than like you can be amazing on the paper with your grades and everything, but you really have to be passionate at least to survive. So passion is super important. So make sure to pick a field that you like, and the statement of purpose, like that's super important, because that's where you're going to portray all whatever you did, what you're passionate about, what you would like to do at the university. You're basically like your rough plan of your life, like a short-term goal kind of thing. So again, for the writing practice, it goes back to my previous one, writing a presentation skill. And the third one is the paper publication. Like that's not a requirement, but it's going to definitely make you stand. So it's definitely going to help you shine separately. So that's also super important. And NYU Courant is really known for ML because there are, in addition to the professors and their cats, there are also these top corporate researchers who work as professors. And I was super fortunate to do the deep learning course under Jan Licken. If you guys know, he is working at Meta AI, and he found the convolution neural network, all the number recognition. He was the pioneer. He was the one who released the data set and did the very first thing in the 1990s. So, and he's the one who proposed the energy-based model and everything right now. And he's like super amazing. He won the Turing Award and everything. So he is a professor there, and I was super fortunate to do a course under him, learn so much more. And these professors, especially, they don't teach what's there in the book. They teach what they learned in the corporate world. How did they come up with that model? What was their idea? Which is super important, which you won't get in any books. That's something you get from the people who invent. And these inventors take courses where they teach you how they invented stuff, which I found pretty interesting and useful in addition to the books. So this is why I really love NYU, to be honest, for ML. And in addition to all of these things, there are like so many research labs under these profs itself. Like if you do very good under their course, like you can work under their research lab, which is going to directly take you to their companies literally, because you show their name. These are like like top researchers, senior researchers, and most of them are in Meta and AI in Google. So there's so many opportunities that it's like a big gateway for you. And what would be the outcome if you ask me? I've only finished my 1 year, but even in this 1 year, I learned so much. I explored so many different fields. We are even allowed to take management courses from NYU Stern. You are free to take across different NYU schools to explore more fields, and you will get a really strong foundation in machine learning concepts. Uh, like literally, they teach you each and everything with respect to math and everything, so much that you will actually start appreciating the math and everything, and you will actually understand what's going on in the real world and what is going on in the current world, not the older versions of the books. And also exposure to opportunities, like I said, like research labs, corporate labs, like everything you can do. Like there's a lot of opportunities to collaborate. So yeah, so if you want to pursue a master's there, you can like always reach out to me to ask any questions. Not just there, like in general, if you would like to apply for hires, you can reach out to me, and I will be happy to help. Next slide, please. Yeah, so drop a hi. I link my LinkedIn and email. Unfortunately, I'm too active in my emails, adulting, I guess. So I should be able to reach back earlier as soon as possible. So yeah, you guys can reach out to me for anything. It could be a very silly question, but I don't consider any question silly. So you can ask me anything, and I will be able to help you out. Yeah, thank you.
Thank you, ma'am. Your take was like very insightful and like informative. And okay, next up we have Vidyaa, ma'am, who will be presenting about perception and control in autonomous systems. And can you take over?
Yeah, so hi guys, and Deepti, that was an amazing information, and it was the information was too high to take in actually. So yeah,
I got only like 10 minutes. I think I went overboard. I'm sorry, guys, if I bored you so much.
no worries. So yeah, I would just go a bit quicker. So my journey till Purdue. I started my journey in robotics with RMI, and the first day I knew about RMI, I just decided that I would just go in somehow. So that's that's because of one thing, the way they presented their content. So as Deepti said, the presentation is very important. Like whatever you do, that should speak for itself, and the way you portray it, that's the best way you can show what you have done. So right from that day on, like I've attended workshops and exhibitions from RMI, and it was the aptitude which they had and which they manifested through the projects were really amazing. So I just went on to do the tasks that they have that they had, and right into the team. And into the team, it was one step higher. Um, the work that had to be done, like the hard work that had to be put in, was really high. And even when I look back now, like I just wonder how things had fallen into place. So I had learned a lot during the 3 years tenure in RMI, and the technical flow was so beautiful that so first I would like to start with what my major project in RMI, which is Pepper. So it's a personal assistant robot which maneuvers in, you can say that Alexa, which can move based on what you say, something like that. So that didn't have a training in it, because the path planning algorithms were finite, and it didn't have a training model to maneuver. So my third year internship, it was in data analytics, so which gave me the new perspective of how training can improve the path planning algorithms present in what the project I had done in Pepper. So I would say that the path planning algorithms got much higher when I started to perceive through training. So we took the Pepper to one step higher, having deep learning and reinforcement learning algorithms for path planning. So we actually also tried to publish a paper for reinforcement learning, and had a novel idea for how to communicate with other robots and move through the dynamic obstacles. So as Akshaya had said earlier, like path planning is itself an ocean, and once you go deeper, and there's still so much work going on, that you would just feel a drop in the ocean. So yeah, so after this project, I moved on to Harman, where I worked in the automated parking systems. So in car platforms, in autonomous systems right now, in Waymo, or in this Geizo. So all these companies, like, they have 5 levels of automation. So the highest level of automation is still has so much to be explored, and Waymo has been like the best so far. And so in Harman, we cater to these features for some OEMs like Tata and BMW. And so my part was to work in cross traffic alert and surround view features for automated parking systems. So these terms I just put in here, like, so that when I see some terms which are new to me, right, so I just Google it, but the essence of it will not be captured immediately. So I wanted to just share whatever I had learned through these years about these terms. So perception in autonomous system, what does it exactly mean? So yeah, can you go to the next slide? So perception is nothing but the camera, the vision part of any maneuvering system, which is trying to be an automated manner. So yeah, so these are some of the techniques currently present, and these state-of-art technologies, like they do have some inaccuracies, and some places where it can be improved. So yeah, there's something called a SLAM, simultaneous localization and mapping. So say there's a robot in an environment, so it doesn't know the environment as well as it doesn't know its own position. So to know its own position, it does something called as localization, to know where it is, and to know the entire surrounding, it creates a map on its own. So this is done simultaneously, so that the learning is at an efficient rate. So this SLAM is again a word in itself. There are many techniques to do this, and using different sensors such as lidar, radars, and camera visual odometry, as well as ultrasonic sensors, etc. And what I had learned from RMI and the corporate setup is that the sensors input is completely different compared to the ones which we use in research labs. So the data is high at a high rate incoming, and these has to be there has to be a training model in itself to get in the images and process it. So I was like I admired the way the code was moduled and structured so that each and every module has its own component and it works independently, as well as the communication between the modules was so neatly structured. So that's how I learned the impact of modularity in code. So when I used to code as a undergrad, like I used to put everything in one place and I used to mess things up. So I learned to how modularize the code. And one more thing, as Deepti said, like whatever you code, you just try to avoid copy paste. So that whatever you do, learn it and type it on your own, so that it will get registered in your mind, and that's how you get the fullest of the concepts. So yeah, so this slam is one main component in perception. And this semantic segmentation is purely using images. This is done using convolutional neural networks. So CNNs are nothing but like taking a picture and dividing it up into several small parts and use something as powerful as a GPU. GPU is nothing but it parallelizes the work. It just distributes the work to multiple small segments, and all of them are done parallelly, and the outputs are combined together to get the output in a faster manner. So yeah, so frankly, it took me a lot of time to understand what CNN is and how it's efficient. So yeah, so and then yes, so SLAM and segmentation, semantic segmentation doesn't involve training, but now there are sensor fusion techniques to implement training and deep learning onto the SLAM. So that's how we published a paper in reinforcement learning. So our theory was to have multiple bots and have a decentralized communication between them using reinforcement learning techniques. So you do not know the real world, you localize and simultaneously map the environment, and that mapping should be efficient because the maps need not be done twice. So the communication between them has to be in such a manner that you cover the entire environment in an efficient manner. So yeah, there are like these terms, I found it really useful because see, today in today's world, like you just within a click, you just get a lot of dump of tech terms. So I just try to put it all in a bunch so that you could understand. Okay, so this A2C and A3C comes under deep learning and reinforcement learning, and how meta learning is different from semantic segmentation. So such terms are useful when you want to learn how it works. Yeah. So next slide. So yeah, so mainly I worked in these two features, where the first one is cross traffic alert, where when a car it has cameras on, or it has 8 cameras basically. So when you take a reverse or in your car, like you won't be able to see the spots. So these are called blind spots. And if say there is some car incoming, so it wouldn't know the car, right? So for our automated park assist systems, we use something called cross traffic alert, and we use some algorithms to find stitch the cameras so that in the entire view is enabled, and the incoming cars are detected using object detection techniques. So yeah, I think these the images show like it's pretty clear in itself. So yes, and coming to why I moved on from Harman to MS is that uh, I felt like I would just need to explore more in this field, and every every single thing inspired me a lot. The way the so my colleagues were all MS and PhD scholars, so the way they viewed each task was totally different from mine, and I just wanted to explore as much as possible. And like within a click of a second they would just tell the output. So to get to that level, like you just need to go to the core depth, and that wasn't possible in UG. So I just wanted to explore and get a complete understanding of what I do. So yeah, here I am to take the next giant leap in Purdue. Yeah, let's see. So yeah, back to student life is a bit scary, so I'm just hoping it will be fine. And as Deepti said, I'm just happy that I'm back to be a student. I'm just going to learn much more, and yeah.
Thank you, ma'am. Thanks a lot. It was almost all of us are very new to this, so it was very insightful and we got to learn a lot.
Yeah, thank you. And you just feel free to contact me. The LinkedIn name is same as the um, tag, the speaker tag. So just actually, I can type my LinkedIn also. You can just add my LinkedIn and Gmail account in my in the PPT.
Okay, ma'am.
Yeah, and those who are coming back to this master's application. So I was really in a confused state as to if I can apply for masters or not during my UG as well as this after 1 or 2 years. So the main reason I'm going to masters is, yeah, as I said, the depth of knowledge in UG is very less, and being in instrumentation and control, like I couldn't get all the courses that I needed. So that's one main reason. And even if I got the courses, it's totally not uh, to the level that today the state of art technology is today. So um, there's an evident gap in that in our UG. So I would say, like, if you're really passionate about about your field and you really want to make a difference in your field, I would say better do masters and PhD. And how work experience can be useful for masters. You get to know the difference between a lab work and a corporate work. The way the system is done, the way the inputs are taken from a car is completely different from a theoretical input or a sensor input from a lab. So I got to do test drives in automated car buses. So those kind of exposure you never get in a lab, right? So that that experience is one thing. If you go to like have if you're planning to have a work experience, it's good to have 2 years or 3 years of work experience, and go for masters, because it will help a lot in the way you answer your interviews also. And yeah, tips for developing your resume towards pursuing masters. The like again, the way you put your lab work is completely different from the way you portray your work in corporate field. So like if anyone has any doubts in your resume, you can just ask me about it. You can just ping me in LinkedIn or mail. So I've been I've been doing a lot of resume reviews now, so it's just been like I tend to see a lot of difference from what I was in UG and now, so I can just help with that bridging the gap. So factors to consider, yeah, this like many juniors have asked me about this, like whether I can go for placements or take up masters right after UG. So that depends on completely your field and your own environment. But yeah, as I would say, if you're really passionate about your field and if you really want to work, make a difference in your field, then it's better to do masters. But even after work, it's definitely possible to do your masters. So that I can guarantee for sure. And yes, the way you look into universities, I felt it was a very important part of master's applications. So writing GRE, writing a resume, LOR, everyone will do that. But selecting a university which is exactly what you need, it takes a really lot of time. I think even Akshay and Deepti would agree with me on that. So, and for especially in my field, like it was really tough for me to first of all, having a clarity of what you need is very important, and secondly, the way the research is going on, so that will be completely different. So while you look for universities and while you decide for the universities you are applying to, make sure you talk to seniors, at least two seniors from each university, because each one will have a different opinion, and it will be really tough for you to decide with one opinion. So as Deepti said, just ask for people. Any random person is fine. Just message in LinkedIn, or there is something called as lunch club. I'm not sure if you guys know, but there's something called lunch club. There's something called Indeed, through which you can connect with people who you want to, and ask as many doubts as possible, because it's going to be a next step in your career, and it should be a very informed decision. So yeah, so that's it, I guess. If you have any doubts, just feel free to ask me and ping me in LinkedIn and mail.
Sure, ma'am. We'd love to learn more from you and connect with you on LinkedIn. Thank you, ma'am, for the in-depth knowledge, for letting us know about your experiences. And thanks a lot, ma'am.
Yeah. Cool.
So next up is Ravitha, ma'am. Ma'am, would you like to speak up?
Sure. I think everyone, Ketki and Varshini, you guys have pressed for time, so I've been asked to keep it really brief. And I'm not a research student like Deepti, or very techie guys like Vidyaa and Akshaya. But I can definitely talk about all of this that I'm talking about is a real world application of through my work. So like I mentioned, can you move to the next slide, Ketki? Thanks. So for the past 7 years in my current company, which I've been with for 10 plus years, I've been working with the autonomous solutions. So what I do is for the entire autonomous area, it's my baby, starting from revenue, starting from product. And so what my company does is provide training solutions to the mining industry. So when autonomous came into play about 8 years, 9 years, our company was really scared, because what we were doing was providing simulator training for these heavy equipment operators. So when autonomous came, where I put a picture of a truck with no driver. So there is no driver to train. So we thought, oh my gosh, what are we going to do? That's our bread and butter of the company. But what we learned is, that's a question I'm going to ask you guys if you've observed the pictures in this. Yes, the mining industry is advancing just like manufacturing. They've been lagging. If you look at the manufacturing industries. They've been lagging in terms of autonomy. Only in the last 5 years, they're starting to really pick up the pace on it. So there's been driverless trucks and robotic drills, and what I've not mentioned is autonomous trains and remotely operated machines, like there's all these heavy loading machines and dozers. They're being remotely operated. And a very popular concept in the mining industry right now is remote operation centers. So people who previously used to be in the mines are now sitting in the comfort of an office and controlling the entire operations. So if you look at all these pictures and some of the things that I initially, the term that I picked up and spoke about, can any of you in the audience tell me why is the mining industry picking up the pace with automation in the past 5 years? Any guesses? If you don't know what mining industry is, many of the things that you guys are currently using on a day-to-day basis, 90% of the things that you are including the electricity is because of the mining industry. It's what we mine from the earth, like coal, iron ore, copper, everything that's used around us, and the things that we use on a day-to-day basis is the result of the mining industry. So why do you think mining industry is moving towards autonomous solutions, and in the past 5 years they're picking up the pace?
Accidents, maybe.
Absolutely, Ketki. It's for the safety. And a lot of countries are starting to legislate that because mining is a very dangerous environment. So when I told many of my friends that I'm in the mining industry, the first question is, are you in the mine site? No, I'm not in the mine site on a day-to-day basis. Our company provides services to the people who work in the mines, so and products. So it's a very dangerous job, which is why I think simulators come into play. So before you put yourself in harm's way, you do proper training in the simulator and then go. So next slide, please. So absolutely, Ketki is right. It is to keep people outside of harm's way. So to achieve zero harm, to increase the safety in the mines. And another thing is to drive productivity. Because obviously, as people, we need breaks. And, when it's all shift work in mining. So when they change shift from, some mines have 8-hour shifts, 6-hour shifts, 4-hour shifts, whatever. When they change shifts, there's always a downtime in the equipment. And for obvious reasons, like especially trucks, you can't do 24-hour operation if it's not autonomous. Because nighttime, with not much visibility in the dangerous environment. So the solution is, again, make it autonomous, and you can go 24/7. So it's to improve safety and to drive productivity. So other related question, what do you think in order to achieve this using these autonomous technologies? Again, a question to the crowd. What do you think is crucial? How can you achieve that? Yes, I mean, the companies are saying, hey, go to driverless trucks and you will improve safety and you can drive productivity. Is it as simple as just buying those equipment and putting them in operation? If you think yes, any of you can say yes. Well, I think with the silence, I'm going to take that as a no. If we move to next slide. Yes, so to achieve the above, it relies absolutely heavily on the HMI application. So particularly the human side intervention, because that's the one non-deterministic. So all of the others, when it comes to autonomous, the truck, once you put the input on, go from A to B, it will absolutely go from A to B. But if you put that as go from D to A, that's what it's going to do, right? So to achieve this zero harm and to achieve this improvement in productivity, you need these people having elevated skills to drive, to to give the right input to these autonomous machines. So finally, my company found a groove. It's not fully autonomous, manless minds that we are talking about. There is still a heavy element of, like in most of those pictures, you see there is a human controlling the whole thing. So there is a heavy reliance on these humans to do the right input in order to achieve safety. Because if they do the wrong thing, they're actually putting the remaining people in the mine at risk. So that's where we decided, all right, so we'll pursue this human side of training. So whether it's a person in the truck or whether it's someone behind the office, we are going to focus on the human performance side of things. So with that, I'll nicely move into the next slide. So that's my company's specialty, is in the mining industry. Our focus is on optimizing human performance. So we do collect a lot of data regarding human performance. And most of it, because we provide training to these machine operators, most of it comes from the machine, but we don't look at how to optimize the machine performance. That's what the machine manufacturers do. What we do is the human metrics related to that machine performance are the ones that we collect. And we also collect our training data from the simulators. I'll tell you why. Because as Thivyaa pointed out, why people are moving to autonomy is because of the harsh weather conditions and things like that, which is absolutely right as well. So these harsh weather conditions, they don't occur on a day-to-day basis. So when you take data from the real operations, there is going to be variability because of these environmental conditions not being constant. And, there is some people who worked on the day with harsh weather, you will have data on them, but the other guys may not have been exposed to that kind of harsh weather or environmental conditions that we are really looking at. So that's where simulator comes in, where everyone is put through the same environmental conditions, because that's what a simulator does. So we can actually look at more breadth of the data of human performance from simulators. But when it comes to the depth, I think we take it from the real operations, but it will have a lot of missing data. So for the lot of missing data, that's where we take the data from the simulator. And the key focus is on reducing the performance variability between the best person and the worst person. I'm not sure what you guys think. I was naive enough to think, 20 years ago, I thought look, if I'm not performing very well, I'm going to be fired, but that's not how corporate companies work. So what they look at is, yes, there will always be, people who are highly performing, and there'll always be people who are low performers in the company. So to reduce the difference between the two, it improves the overall output of the company. So that's what we are focused on. So we usually take the bottom people and we provide training, and we improve the mean average of the entire overall company size. So that's our science behind data and analytics, and it's purely optimizing human performance. Next slide. This is some completely, I don't think any of the other guys have touched on it, but when you enter into the corporate world, and especially in the last 4 years since 2018, data privacy has become a huge thing, that it has created a lot of job opportunities around the world. It is because back in 2018, the European Union came out with this thing called Gdpr, which is General Data Protection Regulation. The gist of it is to protect an individual's personal data and how it's processed. So it's to protect our own data. Yes, it's European Union, and many of you might ask, well, if you're living in Europe, you may get affected. How am I affected? But if you look at most of the companies, they are multinational companies right now. They are either selling goods and services to European companies, or they could be dealing with European people's data. So either of that comes into play, that means you have to comply. So 100% of multinational companies have to now comply with GDPR. So it applies to, I think, Yahoo and whomever are working for these big corporations like Amazon, Google. It applies everywhere. So what this has done is made corporate companies look at what personal data are we storing and how are we storing it and how are we processing it and for what are we using this data. And that's not an easy task, let me tell you. It is a huge, huge task. And most common job title that it has created an opportunity for is its data protection officer, which is part of, if you look at the entire regulation, if you read I think it's about 80 pages or something. If you look at it, there is a role called data protection officer that's mentioned in the regulation who they're saying that there should be a role in your company such as data protection officer who's responsible for looking at what personal data you're collecting, how you're using it, are you making sure it's being processed as what you're telling your users, this is the reason we are collecting and this is what we are doing with it. And after its use date, that we are deleting it. And if someone comes and tells you that, it's called right of data. So if they want the data to be deleted, you have to abide by it. So in the last 3 years or to 4 years, you would have seen many of these subscription emails will have unsubscribe link at the end of it. And previously, if you remember 4 years ago, it's very easy to subscribe to something, but they would make it incredibly harder to unsubscribe. So I remember those days a lot, but now you can't do that by law. And if you don't abide by this, the penalties are quite hefty, and you can see up to like 20 million euros potential penalty per incident of things that they've not obliged by. So there is plenty of job opportunities out there, and it's a big thing. So data privacy officer, manager, I think people have some fancy titles. The key title is data protection officer. The rest is in there. I know we are pressed for time, so if any of you are interested in any of these things, feel free to contact me. If you try hard enough, you will find who I am and how to get to me. I'll leave it at that. Thank you.
Thank you, ma'am. I was very interested in your speech, as in I've grown up, I was born and brought up in a colliery. So I've been to a lot of coal mines.
Wow.
And yeah, a lot of coal mining sites, and almost my entire family works in the coal mine business and the coal field sector.
Mm-hmm.
So
awesome.
it was really great, ma'am. Thanks a lot. Akshaya, ma'am, would you like to begin now?
Yeah, can I share my screen? I have a few videos.
Yeah, sure. Yeah.
Okay, let me know if you can see my screen.
Yeah, your screen was visible now.
Okay. So hello everyone. Hi again, Akshaya. I'm working in robotics, and today I just thought my aim today is just to get you guys inspired about the different things that I'm doing, and hopefully get you guys to do some research from your end to see what's going on in these fields. I'm working on multi-agent systems. So the main challenge in multi-agent systems is to have the different robots communicate properly, coordinate properly, and also make sure you know who is doing what. And these kind of systems have a wide range of applications. Some of the applications that I'm working on are listed here. That's exploration, surveillance, search and rescue, and construction. For example, this video shows the second case, which is search and rescue. What's happening here is, say you have a warehouse environment. This is a Amazon warehouse environment, and say there is a hazardous situation. Say there's a gas leak. Now, you want to send in a bunch of robots to do multiple things. For example, you want to search for victims, you want to search for possible sources of gas leaks. Say these are the two things you want to do. And you have experts, right? So, say they have some kind of idea about where this can possibly happen. The pink dots you see on the screen are possible regions where you might find a victim. And the yellow dots that you see over here are possible points where you can find a gas leak. Now, when you send in a robot, you want it to explore the area and you want it to spend high time in these regions of purple or pink dots and yellow dots. So this is a possible application where you have both task allocation and you also have coordination. Another interesting field over here is construction, which I recently started working on. And this is exciting because I never thought we could do so much with multi-agent systems in construction. And I think this also overlaps a little bit with the mining industry work, where here you have multiple agents, the green moving things. It's a little bit fast, but if you spot there are 4 green blocks moving around, they are robots. And the pink blocks you see on the 4 corners are places from where it can get additional blocks from. The aim of this problem is you want to build a 3D structure that's specified by the user. And the 3D structure here is represented by these shaded brown blocks. And if you see a block with a green outline, that means the block is placed correctly. And a red outline means the block is placed incorrectly. This is a training episode that you're seeing right here, where the robots are just putting blocks and learning whether it's doing it right or not. Here again, the task is coordination, because you don't want one robot to actually place it in the correct place and another robot to remove it from there, right? So you want good coordination, and you also want good task allocation. And finally, when you talk about any of these multi-agent systems, maybe in the first example that I showed you with search and rescue, or in the second example that I showed you with construction, one very important thing is simulation and testing. This, I think, is applicable to any field, and in particular to robotics and things that involve a lot of hardware. In the beginning of the session, I spoke about path planning, so I think that's really nice that it connects to this. Here, I am just trying to do basic navigation from a given start location to a goal location. How would you go about starting from an algorithm to testing it in simulation and then actually seeing it on a robot? This is what you will be doing. So say there is a start and goal location. The circle is the start and square is a goal. So say this is the problem you want to solve, all right? And green is for one robot and red is for the other robot. What you would ideally do is first write a kind of algorithm that does this for you in any language, say Python or C. You can visualize that using something like MATLAB or just image in Python itself. Once you have that, it is really helpful for you to learn a tool like ROS, which is Robotic Operating System, where you can visualize the working of the algorithm using the robots itself. For example, in this video, you can see 2 robots, and the dots are the path that's being planned and the robots following that path. This is very important to do because when you're visualizing it in Python, there are high chances you're not taking into account how the actual robot will move, the dynamics of the robot, or you have not taken into account the size of the robot and things like that. So it's very helpful to do the visualization on something like ROS. Now, once you have this done, the next step is to have it run on actual robots. Now, this video, I don't know how much you can see. This is outside our lab, and here we kind of have two small, really cute robots called Rospots. And here they are following a path that's generated by the algorithm, which is a little more complicated than this L-shaped path. And you can see them following. Now here, when I was doing the testing, I realized there is a lot of difference between the robots actually following the path and the algorithm saying, yes, the path is found. There can be like an obstacle that you see over there, a rack, which many times my robot toppled over because it had a camera that was above the LiDAR. And so the LiDAR said it's free, but the camera was actually getting hit by that obstacle. So yeah, this is a very good practice to do. And if anybody is interested in learning or starting off with multi-agent systems, algorithms, this is a good curve to follow. You might not have access to robots like shown in the last video, but you can definitely do step 1 and 2. And I think that's a very important skill and a very nice skill to have if you can do proper simulation and testing of your algorithms. And finally, I will keep it short in the interest of time. Yeah, this is me. I'm currently working in the biorobotics lab at CMU. It's called biorobotics because it does a lot of things involved with snake robots. I'm currently not working on them, but I'm working on multi-agent systems. And if you would like to chat further about where do I start, what are the good skills to have if I want to apply to the robotics department at CMU, or any other good projects that you want to start on, feel free to hit me up, answer my email ID and my LinkedIn account. You can drop in a message and I'll get back to you.
Thanks, Akshaya, for giving us an overview of multi-agent systems, and also your small sneak peek of your simulations and your testing. So now we'll move on to the Q&A round. So I'll be putting up a link in your chat box. So if you guys have any questions for all the 4 speakers, do add your questions there.
அவர் ரொம்ப ஓவர் திங்க் பண்றா நீ ஒன்னும் யாருக்கும் கேட்கலையே நீ அவங்க பண்ணாங்கன்றதுக்காக கிரேட்ஃபுல்லா இருக்க அவ்வளவுதான் நீ அவளுக்கு பேசவே பேசாத ஷீஸ் லைக் ஓவர் திங்கிங் கேர்ள் வேற லெவல் ஓவர் திங்கிங் see your friend gave you இவ்ளோ உனக்கு கிரேட்ஃபுல்லா இருக்குல்ல see நீ வந்து இவ்ளோ கூட சொல்லி கொடுத்த யாரு அவ ஏதாவது கண்டுனால வருவா வந்துட்டு அப்புறமா அவதான் வந்து போயிட்டே இருப்பா சரி கொஞ்சோண்டு ஏதோ ஒன்று சொல்லி கொடுக்கறதுக்கு யாரும் இந்த அளவுக்கு பண்ணணும்னு அவசியம் இல்லை அண்ட் நீ பாட்டுனா அவன் ஓவர் திங்க் பண்ணுவாடி அக்ஷய்க்கு மட்டும் எதுவுமே சொல்லாத ரொம்ப ஓவர் திங்க் பண்ணுவாங்க.
While the girls are typing away, I just thought I'm just so proud of the great work you guys are all doing. Akshaya, Vidyaa, and Deepti. Awesome. Go girls, go.
Yes, actually, thank you so much. And it was really exhilarating to know that autonomous systems have such a great impact in mining industry. I haven't given it a thought, and this perspective was really enlightening. Thank you so much.
No worries. In Africa and Brazil, it's been legislated as a minimum, they've got to have some kind of collision avoidance and proximity detection as a minimum. So they can't just have manual operation throughout. So it's going to get even more interesting in the next few years.
great.
And you have to.
Yeah, that was very exciting because I remember recently talking to somebody from Caterpillar, and they are doing this mining and autonomous mining. It's really interesting to see how they're handling such huge machines.
So by the way, yeah, Caterpillar. So our parent company is Komatsu. So Caterpillar, Komatsu, they're all they are the main two competitors in the market when it comes to the autonomous trucks. But yeah, so we provide training solution. We don't care which manufacturer, which OEM it is, whether it's Caterpillar truck or Komatsu truck or Liebherr truck. So we provide solutions to all of them because most mine sites do have a mix of fleet. They don't buy just from a single OEM. They have some Caterpillar trucks and they have some Komatsu loading machines and Liebherr trucks and things like that. So our training solutions are or whatever are for our customer, so we don't care what machines they have. But you guys will be like snapped up by these Komatsu, Caterpillar, Liebherr, because they're all looking at automation, and path planning is a challenge for all of them. But yeah, Caterpillar and Komatsu have solved it. They're still improving, and whatever work that you guys are doing, I guess, yeah, I mean, they will just snap you up like that if you apply for them. It's a good time.
Yeah.
Okay, so these are the questions. So, like, Ravitha or anyone, can you guys start? Like, can you guys pick a question?
Okay, I think I would answer for the control systems question, the first one. Uh, is that fine?
Yeah, sure, ma'am.
Yeah, okay. So, control systems is a very broad term. Control, as such, it involves, it's more application oriented, I would say. So, uh, for autonomous systems, say, for autonomous system itself, we have 2D vehicles like cars, and you have 3D drones, like which is autonomous, like coming up to be autonomous. And the control for the two, vehicles are totally different. So, how would you motivate them to keep? Yeah. So this math behind the control systems is a research field in itself. So control system involves, basically, according to my understanding, it involves three broad topics. So one is the path planning side, where the control part is based on the feedback from the sensors. And you give a, like, there's a loop, there's a control loop, and you try to solve that loop. And so that comes under one broad category. And the control in industries, the control systems present in industries is a totally different. It uses control in different form. So as to say, like, if you take PID in control systems, like, that uses a basic tuner, and the coefficients for the PID is fixed for one particular instrumentation, for one particular manufacturing industry, say some product. If you have to control the feedback from it, that the parameters are going to be fixed. So the math behind it is comparatively easier compared to the autonomous systems that you work on. So I would say control systems, you would have to narrow down more and understand which part of math you want to, really go into. So there's a lot of scope in both, like instrumentation as well as this autonomous systems. So what would you recommend? Meaning, um, okay, so control, there are many courses for control systems. I can recommend that. And like I can give you the links for some online courses for control systems. But yeah, I can say that there's a course in Coursera for control systems. It's by Magnus. I forgot his full name. So, but he's really good in control systems. That course I can recommend. But yeah, again, you just narrow down to what field in control systems you want to learn, and math behind it involves linear calculus and majorly linear calculus, like Kalman filter, extended Kalman filter. Those topics will be covered in that course. Yeah, I hope I have understood. I mean, I have answered the question.
Thank you, ma'am. Thanks a lot for answering. I think Deepti ma'am would like to answer this question. How do you keep up with current trends in ML, different algorithms being developed every day?
Yeah, I saw that question. So what I would say is that one thing that I do is that I follow the two kinds of people in LinkedIn as well as Twitter. These two are the great sources. One is the research scientists at different corporate labs, where when they publish a new algorithm or a new model, they post it, they flaunt it around, right? Like they're going to post it saying like, hey, here's the paper, here's a short blog we wrote about it. To know more about it, go, like follow this link. So that's one way of being notified of what's going on. And the other way is there are a few bloggers, especially in Twitter, where they write about all of these works, or they more like question, like, so I came across this interesting work, just dropping it here. That those kind of guys. So those kind of guys are also like super useful with respect to getting exposure to what's going on in current world. And so these two are the main things. And when they post, like I would usually like go for the paper directly, because even though the blogs looks shorter, they would skip a lot of details which might be crucial for a better understanding. So you might be in a haphazard like understanding of the concept, which is not going to help much. So I would directly just jump into the paper and like read bits and pieces here and there to see if it's useful for me. If it's not useful, I won't focus much, like along those lines. So if it interests you, that's a different line of thought. So I think that's one of the best ways to be informed. And I also saw the other question: how do you go about debugging errors in ML? So I'm not sure what kind of errors you're talking about. If you want to like unmute and be more specific, but the usual kind of errors that I see in projects are either along the lines of package dependencies. There are a lot of um, errors with respect to two packages, two versions of different packages not going along with each other. That's always a pain. But what we can do is, once we sort it out, we can be a good citizen and we can write it somewhere so as no one else goes through that pain. And the second kind of error, especially with respect to the models, is the dimensionality of the data with respect to every layer in the architecture. So each layer will take different dimensions of the data. That's part of the architecture if they're using a model from the GitHub. So in that case, the only way to understand or to debug is to understand or look into their uh, model code to see what the input dimension require. That's like they would pretty much explain everything there in the comments at least. So that's the only way to debug the dimensionality problems. If I didn't cover any other kinds of errors, like please feel free to unmute and ask.
I think they'll only be able to type their questions.
Okay.
Yeah. So
I
would
can take,
anybody like to pick up? Yeah.
yes, I can take the in interest of doing projects, I see that almost everything has a detailed solution on the web, which I feel is great for beginners like me to learn. But how does one get to publishing such projects? So I'm going to answer that in a generic way, because I think there are some questions in here. I can see you guys are struggling and literally want someone to just tell you what we do. But none of us in this group are going to tell exactly, specifically what you need to do. As an example, I can understand whoever has asked the question, your confusion. But it's like every day, like, there is, you take any product, there are different brands of product, but there will be some brand that stands out. You have to question why that brand stands out, because it's got some originality, because it's got something in it that makes it stand out. So do not worry about if there are lots of similar things that you feel like publishing is already on the web and therefore yours will not be useful. I don't think that's the case. Even if there are many, if you put your mark on it, and if your why is very strong as to why you want to do things in that area, and start with, like Deepti said, your problem statement as to what you're planning to achieve with publishing that paper. And if that why is strong, I think people will notice your paper more than anyone else in the area, because people don't buy, I mean, it's even for the products, they don't buy what you do, they buy why you do it. And Apple is a great example of that. If there are any Apple fans here, I'm one of them. There are phones out there, there are products out there, but the reason why they exist is something that I relate to it, so I don't care. There may be cheaper phones out there, but that's what I want to buy. So that goes for everything that you guys do. It's not just for your projects, it's for the job or anything that you give. I guess make sure you have a clear idea of why you want to do it. Make sure you put your mark on it and give your 100%, and it will shine.
I can combine a few questions here, I guess, about, I saw one question about application to CMU. I saw one question about having multiple interests in robotics. If whoever's handling the slide could scroll down a little bit. Yeah, and robotics has many research areas. Should we do a project in as many areas as possible? Even few projects is enough to get a master's admit. Okay, so I'll combine these three questions. So first about building your resume when you're applying to CMU. For me, I kind of had the advantage of knowing that I wanted to do masters in robotics from like first year. So because I wanted to do masters in robotics, I built my profile that way. But it doesn't matter, whenever you make your decision that, okay, I want to do masters in this field, you start step by step. You cannot jump to writing the SOP for your college applications in your second year, right? That's gonna, you might not have anything to put in there in your second year. So you start with, okay, you're in second year, you want to get an internship in your second year summer, start there and use that experience to understand further what your interests are, to get like LORs or connection network with wherever you're working, maybe a company or a professor, and use that for your third year internship application. Now, after your third year internship, you will have a little more clarity about your interests, and you will also have more network in terms of the professors or managers in the company internship. And then you use these two things in your master's applications. That's how you kind of build your resume. Use one for the other. For example, in my second year internship search, I spoke to the professors about my projects in RMI. And then in my third year internship, like my tax applications, I spoke about my second year internship and my projects in RMI. So you kind of like build your profile that way. Go one step at a time and you will be all right. And the point about having so many things in robotics, and it's pretty overwhelming, I understand. Like, I told you, biorobotics lab, my lab has like 50 odd people doing 100 odd things. So you do not have to have a project in everything. Just pick whatever you like, but whatever you like, make sure you do it properly. You will not be able to get in depth into it, but just do how much ever you can. For example, when I was, to give you context, when I was in my third year, I was interested in robotics, but I pretty much liked anything in robotics. Like Vidya said, when I went into RMI, everything that they did was amazing. I wanted to do everything. But then I narrowed down like computer vision, path planning, and like I was also interested in ML and that side of things. So for computer vision, I ended up doing a project in college that was object detection and obstacle avoidance. It was not like extremely great, but I saw it through, and like Deepti mentioned, try to write a paper or like in a conference, just publish it. It might not add to your application much because it might not be a great conference, but you've completed a project. Then I was interested in like a little bit in ML and things, so we did a project related to that in our final year. Whatever you're interested in, just pick 2, 3 and complete that project. Don't leave it midway. So when you complete a project, you have a small video for the project, you have a small write-up for the project, and you kind of know little, you can talk about that project. That's all you need to know. So yeah, if I've covered things, you do not have to do everything. You can't possibly do AR, medical robotics, multi-agent systems, and all that. Just pick. It's okay to be interested in everything. Pick 2, 3. You won't have time to do everything. Pick 2, 3 and just see it through. Yeah.
I would just like to add one more point to Akshaya's answer. Like, whichever field in robotics you are interested in, suppose, say, you are interested in almost everything, but that just means that you haven't explored really well about each field. So try to Google out what application it is, and if you like that application, go deeper into it and see if you like the workflow to reach that application. Say, suppose there are two major domains in robotics. One is humanoids, and the other is say medical robotics. So how do you know which one to choose? Like, you can't just do both at the same time. Each one would take a lot of time. So I would recommend you go through like 2, 3 applications in humanoids. Does that interest you, and how each is done, the workflow of it? Like, just go deeper and try to find out if that really interests you, because on a broader view, everything would seem really interesting, but at the end it will be really hard to give your fullest if you do not like the way it works. Like the core, if you do not really like it, you won't be able to give your full best. So I would recommend you to try as much as possible to find out what is actually in there for each application in robotics.
Yeah, and one more point to add on to that is most of the fields that's there, they might actually have very common components. Like, for example, if you're interested in computer vision, you will find something related to computer vision in everything in robotics. May it be like autonomous systems, humanoids, in aerial robotics, and everything, there will be some computer vision in it. So if you're interested in computer vision, you can like learn about core or problems like, say, image segmentation, object recognition, classification, or synthesizing images, and that will be applicable in all the fields. You can also do that if you're confused about application, because it will be there everywhere.
Ravitha ma'am, I think this question is for you.
Sure. So I talked about human performance. Human activity forecasting. Forecasting is, when you talk about human activity forecasting, I kind of feel very unethical about it, because that's what a lot of Facebook and those kind of social media platforms. I'm actually against it. They try to their key goal is, and sometimes they openly say their key goal is they want people to be hooked onto the screen. They know when people who are viewing this content, they are prone to viewing similar content. So that's how they provide the news feed. There I don't want to go too much in depth because there is a lot of unethical stuff in there. So when it comes to human activity forecasting, I'm against it. So let me be clear about that. But if that question is about human performance, it's a good question. You can't forecast how a human is going to perform. And just because like for example, if I performed at certain level today, doesn't mean I will be performing at the same level tomorrow. So that's why we always look at a time period of, roughly at least 3-month period of human performance. Otherwise, it's not very meaningful, because as human beings, today I might be in a great mood and, my productivity is through the roof. I'm putting 100% focus. Tomorrow I've got something in my family and there is an emergency and I'm not giving. So taking like 2 days, 1 week, 10 days worth of data for research, it's useless. So you've got to have a sizable data. Because that's what is going to give you some quality and some reliability on that data. But the question about the missing data, that's what I was talking about, which we usually take from the training simulators, is there's a lot of things that are dependent on the external environment that may not happen on a day-to-day basis. Like, for example, in mining, it's a dangerous field that you are in. What happens when the heavy equipment catches fire? Do they know how to respond to that? Our simulators are there to train them for it. In simulators, you can measure that. But for people who haven't invested in simulators, that mine manager and the general manager can't sleep properly at night, because if such an accident happens, they are putting all their personnel at risk. Because if they don't respond to that emergency situation properly, then they're going to have an incident, and many incidents in mines can actually shut down the mine altogether. So that's where the simulators come into play, where these rare situations where you don't know how they're going to perform, but the mines want the safety of these people, and therefore they want them to be ready when such an emergency happens, that they do the right thing. Those are the things they measure in simulator. But like I said, simulator training comes into play once in 3 months, once in 6 months. So there is not too much of data. So you just have to rely on a limited period of data. But on the real operations, the things that they do on a day-to-day basis, you get a much more depth and a quality and reliability of that data that we mainly use for the performance and productivity side of things, and the simulator data mostly for the safety side of things.
Thank you. Thanks for answering, ma'am. I think we are done with the Q&A. So if nobody has any more questions, I think we're good to wrap up. Ravitha ma'am, Deepti ma'am, Vidyaa ma'am, Akshaya ma'am, it was a pleasure and an indeed honor to have you all here. Thank you. Thanks a lot for doing this with us. And this is our last huddle. We had a lot of huddles: software, research, material science, and analytics and robotics was our last huddle. And thank you all for being a part of it. So mentors, I'd like to tell you that you can, if you haven't, you can have your last meet with your mentees before 30th of July. Yeah. So
thank you so much, Ketki and Varshini. It's an honor to be here.
Thank you, ma'am. Thank you. Thanks, everyone.
Thank you so much for the opportunity.
Yes, and everyone, please feel free to reach out to all of us here. I think all of us definitely have things to help you out.
Yeah, thank you all. Thank you so much for listening to us, and it was great listening to other three. Like, I had a lot of things to take in. Yeah.
We'll be sharing a feedback form, so please kindly fill the feedback form.
Sure.
It's there in the chat box. Thank you. Thanks, everyone. Thanks for joining.
Thank you. See ya.